Hello, Mr. Gazda here. 184, Color Your World is evolving. This page of the reference table, it is page 5. Not so much about coloring as it is about seeing how this map works. So here we go without wasting any time. Color all convergent plate boundaries green. Okay, so what you're interested in doing is getting green here. And convergent plate boundaries. This is where you see convergent plate boundaries. It shows that this is the symbol, and the arrows show that that is convergent, means when they're going together. So I'm going to just color over all of these symbols with green. I'm going to do it quickly like this, and there's some here, and there's some here. I'm going very quickly. And actually, I'm doing a pretty decent job with it. So this is where plates are coming together for the most part. Here, a little one there. That's an important one because that affects the U.S., the Pacific Northwest of the U.S. So make sure you get that one. There's a little one there. And part of the plan here is that you understand that convergent plate boundaries are moving together, and that this reference table will show you that fact. Okay. Second one says... to color all divergent plate boundaries brown. So if I get some brown here, and then divergent is this. This is the symbol for divergent. Arrows moving apart. That's a key part here. Divergent plate boundaries move apart. You use that as a hint if you ever sort of forget. And this kind of shows it right here. Okay, the arrow's going apart, and then really it's kind of this, and it's this section here. There's a lot of it. Please also notice that these, almost all of this divergent plate boundary is in the oceans, and seafloor spreading. The idea of seafloor spreading. This is all divergent plate boundaries. Plates are pulling apart. Lava fills in the spot between them, and that's seafloor spreading. There we go. And so these oceans are getting larger right here. In this area here, they're moving apart right there as well. That is number 2. Number 3, all hot spots blue. Hot spots are an area under the crust that is particularly hot. We're not sure why, but it's very hot. The hot spot stays still, and then the plate moves over it, so you get a lot of usually a line of volcanoes over it. And hot spot here, mantle hot spot. There's a number of them on here. Here's one here. The Hawaiian is really a great example, one we use often. Galapagos is right here. Iceland, another really good example, often used in books. Canary Islands, St. Helena, and they've added Yellowstone. Oh God, another good one. Yellowstone National Park is right there with the geysers. So, am I missing any? I don't think I am. Cool. Okay, hot spots. They're on there as well. And then the last coloring thing is for color the Nazca plate yellow. So get some yellow. Nazca plate right here. I'm going to color it yellow. Nazca plate. So see the names of the plates here. It's the Nazca plate, color yellow. Not a lot of coloring on this sheet really. Let's see what we have going on here. Key thing is deep focused earthquakes occur where there's subduction. Subduction is when one plate goes under the other. If I draw a picture of subduction, one plate would go like this. It's the ocean crust usually. When they come together, it goes down. And then you have like continental crust here, a continent right here, usually thicker. And this is when they're moving together like this. This plate going under, that subduction, it melts, forms volcanoes here. And you have deep focus earthquakes down here. So this is where you see deep earthquakes. These earthquakes are deep, these not as deep, these less deep. That's key. Volcanoes and quakes occur at plate boundaries with the exception of hotspots. So at the edges of plates is where you see volcanoes and earthquakes. And new crust is created where plates move apart. Plates move apart, lava comes up between them, fills the gap, and you have new crust. And that's usually what's happening at all of these divergent plate boundaries in the ocean. New ocean crust is forming. Okay, so this is the newest crust here and here as well. So that's key. Applying that in these questions is key. Which point is most likely to experience deep focus earthquakes? We want something on the overriding plate near a convergent plate boundary, a subduction zone. A, B, C, D, or E. So it is a little tricky to look around and find these, but you totally can. And then the answer is going to be A. A right here. The Nazca plate is going on the South American plate. A right here is the best answer. A is the best answer, because that is where you have that subduction. Which location is least likely to have a large earthquake? Okay, near the edges of plates, a plate boundary, good chance of having an earthquake. Far from it, has a lower chance. So A, O, or C, and the answer is going to be O. Not near, just very far from this plate boundary, very far from this, thousands of miles in this case. O is the best answer. The other ones are near plate boundaries, so O is the best answer. 3. Which location will most likely have denser rock, L or M? Okay, so one thing, L is here and M is here. L, the ocean crust is basalt, okay? And the continents are mainly granite. Granite is felsic on the reverse table. It's less dense. The mafic basalt is more dense. Ocean crust is more dense. Continental crust is less dense. That is why the ocean crust will be subducted. That's why the ocean crust goes down here when they meet. And the continental crust is less dense, so it's more buoyant, tends to kind of float on these things here. This more dense will go down. That is a key fact that you just need to learn. Not super obvious, you just kind of know it. So, denser rock will be L. Which location has the older crust, C, D, or E? So, where are we looking? C, D, E. Older crust. Well, new crust is being created here at the mid-ocean ridge. So, this is newest, then this. This is the oldest. There was a time where this was being formed in here. The ocean was much smaller, and then it has since moved away, kind of like a conveyor belt. That is E. 5. In which letter location is the ocean deepest? It's at an ocean trench. Where you have subduction, you have ocean trenches that are the deepest parts of the ocean. So, which lettered location? I don't give you choices here. It's N. Students have trouble because they have to really search around. But this is right in the trench, really deep part of the ocean. Trenches here. The deepest part of any ocean is the Mariana Trench here. So you have that on the ocean side of these subduction zones. So that is N. It's the looking around that really holds some students back on this one. 6. Which location has the rock closest in age to the rock found at L? And those are some choices. The answer here is, let me see. Oh, it's I. I is the answer, because, so, newest rock here, J and G are pretty much the same age. They were back here, and then they since moved apart. H and K are the same age as each other, and L and I are the same age as each other. This ocean used to be kind of smaller here. They were back here, then they've since moved apart, and now they're here. Key concept to divergent plate boundaries, seafloor spreading. So 6 is I. 7. Which location is closest to a plate boundary where new crust is being created? New crust is being created at divergent plate boundaries. Best answer of that is C. So C is here. That's the closest of those choices. Okay. Coordinates of location G. Don't put minutes. So the numbers here, as long as you're kind of close, it's about 60. I had 62. All right. You're off 60. You maybe put 60. You're off by 2 or 3 here. Not the biggest deal. Where students get wrong is either leaving no compass location here. That's bad. Or not having it correct. It is south of the equator, and longitude is about 152. Again, if you're kind of close, that's fine. 154, 151, 155 maybe, but it is west. That is key. West of the prime meridian. Where's G? 155. G is here. Okay, 152. Yeah, something like that. G is right here. 0 is here, so it's west of it. And then also knowing that this is the equator and it's south of it there. This is a bit of review, so really make sure you're on top of this. 9. Which location is closest to a plate boundary where crust is neither being destroyed nor created? Those plate boundaries where that's the case, neither created nor destroyed, are these type of plate boundaries when they slide past each other. Okay. When the plates go together like this one gets subducted, crust is destroyed, or when they pull apart, divergent, crust is created, new lava comes up beneath it. But it's these. Okay, this is a transform plate boundary, and that's shown right here. Know that neither created nor destroyed, and the answer there is of these choices, the answer is M. If you see where M is right here, right near the San Andreas Fault. That's the one that goes through California. That's the closest to it. Transform plate boundary, very good example of it. Often used in textbooks as the example for transform faults. 10. Which location is closest to where subduction is occurring? Okay, where subduction occurs. Subduction is when plates go beneath the other one. Oh, it says subducting here. That kind of helps. You have this convergent plate boundary, this symbol, and your choices there. Of those choices, the answer is going to be N, and let's see, N is right here. That's closest. This is where subduction is occurring. This is on the ocean plate, but this is the closest of those. 10 should be N. 11 is crust being destroyed. You're going to have, again, convergent plate boundary, where there's subduction, and again is your choice of those. You got to look through all of them, find them all on there. It does take some time, for sure, and some effort, but it's what you need to do. Latitude here, as I said, maybe I got 48 at first, but maybe you got 48 or 50 or something like that. Key part, it is degrees north. If you're getting the compass directions wrong, you need to just buckle down and just get it in your head. Know how to do this. This is about 12. Again, the numbers don't matter too much, as long as you're close-ish, and it needs to be west. West is key. Again, compare this to the, what are we doing? F. Location F is here. Okay, the latitude, this is 0. Okay, so it is north of that. That 50 is north. Okay, so it's whatever, 50 degrees north or 49 degrees north. And then, see, 0 is right here, so it's a little bit west of it. So what did I have? Did I have 12? 12. Yeah, maybe even got 15, 18, something like that. Somewhere between 10 and 20, I'll give that to you. But you have to have west. This is 0. It's west of there. Again, a lot of students continue to get that wrong. 13, closest active volcano is going to be A. Edge of a plate boundary. Okay, and A is closest to where the plates meet, which is, again, plate boundaries. Which location is most likely to be closest to an active volcano? Of these, answer is P. Is P as well, again, here, right? You have this subducting here. Yeah, volcanoes on the overriding plate, so P is very close to some active volcanoes up there in Alaska. 15, which is on the overriding plate, P or N? And this is just reading the chart. So you see the box here represents the overriding plate. And then this is the oceanic plate, or the subducting plate in this case. Subducting plate is N. That's going underneath the other plate, so the answer there is P. And then age of crust, GHI. So this is showing the relationship. Again, new crust here. As you go this way, the crust gets older in age. So higher age from GH to I. That graph should look like this. Okay, the relationship here. People still have trouble with this. It's very important to sort of be able to relate this in graph form. And then age of crust from R to F. So check this out. R to F. R is here, F is here. They're pretty much the same age. I made them about the same distance from the mid-Atlantic ridge here. Okay, but as new crust create here, as you go this way, the crust is getting younger. This is the youngest right here. And then as you go this way, they get older to F being pretty much the same age as R about. So, what does that graph look like? Representing that in graph format is, maybe I want to say, oh, let's make these the same age. I'll do that. And then age, high age, low age. It should look something like this. Youngest age right between them to that. Some graph that shows that kind of up-down relationship. Okay. That is 184. This is, this is key parts to plate tectonics. So, watch this again if you need to. Any questions, definitely come see me. For the whole entire staff at GazdaHW Productions, thank you for watching.